The new paradigm is rooted in the realization that emission mitigation did not go as it should have gone. Too much carbon in the atmosphere, too much heat already in the oceans. The new paradigm is about climate repair. Climate repair means repairing the climate, reversing and minimizing the damage that can no longer be prevented simply by reducing emissions. It's about not giving up, not accepting the damage. It's about intervening in the process of deterioration and collapse.
Hello, and welcome to our press conference on No 1.5 Without Intervention. This presentation is a collaboration between the Center for Climate Repair at Cambridge University and the Climate Emergency Forum. My name is Charles Gregoire, and I'm co-producer along with Heidi Brault of the Climate Emergency Forum. The panel will discuss that it will not be possible to limit the global temperature rise to 1.5 degrees Celsius without interventions, which means that in addition to lowering the global greenhouse gas emissions, various forms of solar radiation management and greenhouse gas removal will be required. Professor Hugh Hunt is Reader in Engineering at the Department of Engineering, University of Cambridge, and chair of the Cambridge Climate Lecture Series. He has co-PI of the SPICE project, which investigated the feasibility of stratospheric aerosol injection for solar radiation management, SRM. Dr. James Hansen, who will be participating in this panel via a video recording, is the former director of the NASA Goddard Institute of Space Studies and current director of Climate Science Awareness and Solutions, a program of the Earth Institute at Columbia University. Dr. Hansen is the principal author or co-author of numerous papers on the subject of climate change and Earth's energy imbalance. He is best known for his testimony on climate change to congressional committees in the 1980s that helped raise broad awareness of the global warming issue. Anni Pokela is project manager at Operatio Arctis, a youth-led science communication project based in Finland with the objective to preserve the Arctic sea ice. She is working to prevent Arctic tipping points by promoting socially just climate repair interventions. She has been involved with some of Finland's most influential climate campaigns. And so without further ado, I turn it over to Anni.
Thank you. So, as you can look at the screen, there's a picture of the Arctic Sea. Well, no matter what we do with our emissions at this point, the Arctic summer sea ice will be lost. The year-round sea ice has had it. It doesn't need any more higher greenhouse gas levels to be destroyed. So even if we would cut emissions the fastest way, which we obviously aren't doing, we are still facing things like permafrost melting or thawing, which will release even more carbon dioxide and methane into the atmosphere. And as the ground collapses, infrastructure is destroyed, people's houses are washed into the sea. Our food safety is threatened, and especially indigenous communities are, as ever so often, on the front lines of these impacts. And just the sea level rise caused by melting of ice sheets would in itself basically mean the collapse of civilization as we know it. All this means two things. It means we are facing an Arctic climate catastrophe, and it means we should be searching for and developing additional ways to stop this, which we are not doing right now on a scale and pace that would give us a good chance of preventing this catastrophe. Because right now, the civil society, government actors, and the private sector are not even giving an opinion on saving the Arctic sea ice. I have more bad news. No matter what we do with our emissions, we are already past the 1.5 degrees threshold. 1.5 degrees happens to be the estimated tipping point for 4 major Earth system elements: the Greenland ice sheet, the West Antarctic ice sheet, the tropical coral reefs, and the abrupt thaw of the boreal permafrost. Beyond 1.5 degrees, it becomes likely that all of these systems will start collapsing. So 1.5 is gone, safety for the major ice sheets is gone, and the Arctic summer sea ice is gone, even if we cut emissions rapidly. Let me stress this, a lot of damage is already locked in. So while we must cut emissions rapidly, we must also ask ourselves, is it enough? Now, in our society, we have this old climate paradigm, and the old paradigm says, it is enough. It says, let's cut emissions and hope for the best. In this old paradigm, we don't really take responsibility for preventing any specific changes or collapses. This paradigm doesn't state which ecosystems we need to save, which parts of the climate system are essential and to whom, which things we cannot afford to lose, which things we hold dear, which things we love the most. Now, this old paradigm dominates our society. Bring down emissions, hope for the best, and adapt to the rest if possible. A huge amount of damage and death is already accepted. The old paradigm was born 30 years ago, and a lot has changed since then. This paradigm doesn't serve us anymore. Our governments are stuck in the past, struggling to hold on to that old idea, the old story, the story in which the immense level of suffering is unavoidable. Stuck with what we in Operatio Arctis call politics of accepted victims. The new paradigm is bring down emissions, intervene with the climate changes that are already underway regardless of emission cuts, and adapt to the rest. The new paradigm is rooted in the realization that emission mitigation did not go as it should have gone. Too much carbon in the atmosphere, too much heat already in the oceans. The new paradigm is about climate repair. Climate repair means repairing the climate, reversing and minimizing the damage that can no longer be prevented simply by reducing emissions. It's about not giving up, not accepting the damage. It's about intervening in the process of deterioration and collapse. Climate repair is about zeroing emissions, removing greenhouse gases from the atmosphere, and in addition, repairing and providing active support for the parts of the Earth and climate system that are already breaking down. There are potential techniques for this, climate interventions. Techniques that make the Earth more reflective, techniques that boost the carbon uptake of the biomass, techniques to support the glaciers. But let me be clear, they do involve risks too, just as the current trajectory does. It's yet to be proven whether they or some of them work for the better rather than for the worse. And they are useless in the end if we don't also cut emissions rapidly. But there is a chance for climate repair, and it's quite a promising one. Now, people often reject the idea of climate repair on the grounds that, among other concerns, climate intervention would somehow lower the motivation to cut emissions. And there is a risk, and we need to take those risks very seriously. Some of these issues, however, may be solved, while others need to be compared to the risks of inaction. Comparing the risks requires a clear picture of the risks, and to achieve that knowledge, we need a lot more research. We must examine and investigate the ways for climate repair. We must adopt the new paradigm, reduce emissions, and support the Earth's most vulnerable systems. Even if it's difficult, even if it's challenging or uncomfortable, even if it would lead us to rejecting climate intervention techniques. Because that's the thing, even to that conclusion, we must arrive through a new paradigm and not by simply accepting the damage that's unavoidable without them. We have a moral obligation to ourselves and to the young people and to the communities on the climate front lines to ask ourselves, are we truly ready to accept the damage that's unavoidable without climate intervention? Or are we going to give climate repair a chance? And now to shed some light on the science behind the need for additional measures, we are going to hear from James Hansen.
Thanks very much, Jeff. And thanks to your people and your program for hosting this discussion.
We're honored.
And I also want to thank my co-authors for their unique scientific expertise and contributions to this paper. and the editor-in-chief of Oxford Open Climate Change, Ilko Rolling, for inviting me to include my perspective about policy implications, which is the final section of the paper. So the climate on our remarkable home planet is characterized by delayed response and amplifying feedbacks, which is a recipe to lock in intergenerational injustice. So we climate scientists have an obligation to explain this situation clearly as best we can, especially to young people, and to include the policy implications. Because if we don't include the implications, people who have a special financial interest will make their own conclusions. Together, these imply a climate sensitivity of about 4.8 degrees Celsius for doubled CO2. IPCC's best estimate of 3 degrees is excluded with greater than 99% confidence. This high climate sensitivity has major implications for global warming in the pipeline. So aerosols are fine airborne particulates. They are a health hazard, killing several million people per year. Aerosols also cool the climate by reflecting sunlight to space, their main effect being as condensation nuclei for cloud drops. They slightly increase cloud cover and make clouds a bit brighter. Humanity made a Faustian bargain by offsetting a substantial but uncertain fraction of greenhouse gas warming with aerosol cooling. Now, as we want to reduce all the chronic health effects of aerosols, our first Faustian payment is due. The payment is acceleration of global warming. Conclusion, the 2 degrees Celsius global warming limit is dead unless we take purposeful actions to alter Earth's energy imbalance. The first thing that we must do is reduce emissions as rapidly as possible. But fossil fuels are providing most of the world's energy, almost 80%. The task is to reduce the carbon intensity of global energy to near zero. But we reduced it only from 0.8 to 0.7 in the past half century. It's not plausible for it to go to near zero by mid-century. Now, my last chart on the fundamental required actions, none of these are occurring. A rising carbon fee is the fastest, most effective way to affect all uses of fossil fuels. But the fossil fuel industry has prevented it. Instead of East-West cooperation, our politics and special interests have led to a focus on economic and military hegemony, which is foolish because we are all in the same boat and will sink together if we don't work together. I don't think that anyone asks young people if this confrontational approach is the kind of world they wish to aim for. The 1.5 degree limit is deader than a doornail, and the 2 degree limit can be rescued only with the help of purposeful actions to affect Earth's energy balance. We will need to cool off Earth to save our coastlines, coastal cities worldwide, and lowlands, while also addressing the other problems caused by global warming. Now, it will take several years for socialization of what is needed for the public to understand. which will be aided by the increasing problems that they will see from global warming. That several years will provide the time that young people need to understand this matter. And specifically, the fact that I believe a political party that takes no money from special interest is probably an essential part of the solution. Young people should not underestimate their political clout. Thanks.
All right, that was James Hansen, and now we'd like to hear from Professor Hugh Hunt.
Thank you very much. I'm from Cambridge University in the Centre for Climate Repair, and following on from Jim's comment that we need to take action to restore energy balance. Well, energy balance is all about refreezing the Arctic, reflecting sunlight. At our Centre for Climate Repair, we've got 3 missions, 3 R's. One is to reduce emissions, one is to remove CO2 from the atmosphere, but the third one is to refreeze the Arctic. I want to talk a bit about how we might go about doing this. These are interventions, you might call them geoengineering, you might call them climate repair, interventions to cool the planet. And these are the interventions that Jim and Arnie are talking about. The blue ones are about removing carbon dioxide from the atmosphere, but the ones that are going to happen the quickest, the ones that are going to affect the Arctic the quickest, are the green ones, altering Earth's radiation balance. And there's 3 I've got here. One is on marine cloud brightening, another on cirrus cloud thinning, and the third one on reflective aerosol particles. I'm going to talk mainly about the first and the third of those green ones. If we think back to 1991, we know that when Mount Pinatubo erupted, it caused a cooling of the planet by nearly a degree over a period of about a year. So a project that I was involved with about 10 years ago, the SPICE project, standing for Stratospheric Particle Injection for Climate Engineering, was looking at how we might use the science that Mount Pinatubo told us about to change the optics of the atmosphere, as you can see in this right-hand picture. And to do that, we started thinking about, well, how much stuff, let's suppose sulfate aerosol might you have to put into the atmosphere to cause a cooling of 1 or 2 degrees? And how would you get it there? So all of a sudden, this stops being a question about climate science. It starts being a question about engineering. How do we do it? So there's a list on the right-hand side here. You know, could we put this stuff up at 20 kilometers with aircraft or airships or missiles, or how might you do it? We chose to look at technology of using tethered balloons to do it, mainly because the idea of thousands of aircraft delivering this stuff seemed to be, well, not ideal. But the options, it's important to start putting numbers on things. How long might it take to develop technologies? What technologies might we look at? Which ones are desirable, which ones are not, and how much does it cost? Interestingly, probably cost is not a factor of great importance, but time, well, we're running out of time. We've got to get on with things because the Arctic, as Arnie was saying, the Arctic ice hasn't got long to go. So if we think of development time, even in the best options of 5 or 10 years for these particle delivery techniques, we need to get on with the research now. The problem, of course, is that things are controversial, and this was a headline relating to our project 10 years ago. Our test was cancelled, and for various reasons. What do we do? Okay, so we sit, wait, and see when we can get on with research. Well, now I think is the time. We've got to get on with it. Marine cloud brightening is perhaps less controversial than stratospheric aerosols. If you think of this picture on the left shows ship tracks. So ships are powered by fossil fuels, by bunker fuel, and the ships, there used to be a lot of sulfur in that fuel. Less now, but there used to be a lot of sulfur in the fuel. And that sulfur would nucleate clouds. So the question is, maybe if we can make more clouds, whiter clouds, as Jim said, we could reflect some sunlight. Well, they're doing exactly this in the Great Barrier Reef in Southern Cross University. It's called marine cloud brightening, and it's actually, you can use 3-letter acronyms very helpfully online. If you search MCB, GBR, SCU, it'll take you straight away to a lovely video. It's about 2 minutes long. Do watch it. It's about how we can artificially create the sea spray that waves, the picture on the bottom right, do naturally. Can we create more sea spray by spraying salt water and creating droplets? Well, we might think, how do we do it? We need a lot of boats. How do we design those boats? Or maybe we can attach the spray to existing devices like wind turbines. Well, these are the questions that we need to start asking if we're going to even begin to use these techniques. Now, in Cambridge, we're looking at how do we make the droplets. We need to make billions and trillions, 10 to the 18 droplets per second is the kind of figure we're looking at. And if you think about a pressure cooker on the left-hand side, you could think that there are lots of tiny droplets, superheated steam. Well, that's one way we're looking at producing droplets, but we've got to figure out how to do that with salt water and reliably and without the nozzles blocking up. But then we started looking at another way, this thing, electrospray, high voltage, 10,000 volts on little droplets, producing these streams of droplets. Again, producing 10 to the 14, that's one with a lot of zeros after it. It's a big challenge. And then we started thinking, well, maybe we can use silicon-based fabrication, because you can put lots and lots and lots of nozzles onto a silicon wafer. And there's a picture of the silicon wafer on the left. Stephen Salter in Edinburgh was a great champion of this. So all of this stuff is about the technology to do the things that Jim and Annie are talking about. So we can't really think about the problem. Yes, we've got to do some kind of climate intervention, solar radiation management. We've got to think of what the technology is. And so here are some big unanswered questions which I will leave you with, because if we're going to do stratospheric aerosol injection or marine cloud brightening, then this is a list of the research areas which I think we've got to be dealing with. I won't read this list out, but if you want to have a look at it, you'll see that there are some pretty interesting things we've got to get the answers to. So I'm going to hand back to Annie to sum up where we're at.
Yes, thank you, Hugh, so much. I just want to wrap this thing up by saying that I want you all to know that this is very serious. I am really serious about this. We are facing some catastrophic things if we don't explore climate interventions. We were just talking to my friend Ricardo Pineda Guzman from Honduras, and he said, in a very, I completely agree with him, he said that not researching these interventions is an attack on our basic human rights as young people, and especially for him as a person from the Global South. So we need to explore these interventions if we want to prevent an Arctic climate catastrophe. Thank you, and I think we do have some time for some questions now.
Thank you, John Liu. I'm just wondering, how long do you think it would take if you were able to get the ideal situation for restoring the cryosphere on the coals? How long would it take to see results?
Thanks very much. Well, we know that from volcanic eruptions that, say, Mount Pinatubo, after the eruption, the temperatures dropped rapidly. And we know that when you drop temperatures, you at least slow down melting of ice. We've got, at first thing, is to slow down the melting of ice. Restoring the ice, well, hopefully we can achieve that as well. Regionally, you might consider looking at techniques to thicken ice in the Arctic, which requires techniques in the Arctic winter as well as in the Arctic summer. But the idea of changing reflectivity is far more rapid than changing our emissions. Changing our emissions will take decades, centuries, whereas reflectivity approaches will be quick.
Hello there, Martin Siegert, University of Exeter. I'm a polar scientist, 30-odd years. I know your work is controversial, and I probably add myself to the people that will criticize this type of work. I don't know any polar scientists that think this is a good idea. We've geoengineered the world already, and to add another layer of geoengineering on top of it without reducing emissions to net zero, I think is costly, I think it's distracting, I think it's impractical, I think it's dangerous. And I think we should only treble our efforts to reduce our emissions. That's the only approach. Thank you.
Thank you so much, and I really do appreciate people being concerned about these things, about concerned about the risks, concerned about emission cuts. It's very, very important, and it makes me happy that people care about emission cuts. And as I said in my opening speech, is that these techniques are useless in the end if we don't cut emissions rapidly. So what we think in our project is that we need things in addition to those emission cuts. I would not want to be here talking about these interventions. They scare me, and I'm angry, and I'm saddened, that we've come so far that we have to discuss these techniques. But we are facing catastrophic things if we just cut emissions. And for people to say that let's not even research these, I'm not speaking for deployment. None of us have the correct information, the right information, or the information needed to go, even talk about deployment. But for people to tell me that we shouldn't even research these things, for me that means accepting the damage that's unavoidable with just emission cuts. There are so much suffering, so much death that's going to happen with just emission cuts at this point. And even if we come to the conclusion of never deploying these intervention techniques, and I hope that we won't have to deploy them, even if we come to that conclusion, I think the right way to come to that conclusion is first to research them so that we have the correct information to even compare the risks of those interventions to not using them. So this is what I think. And I really appreciate the criticism, and I want to be very critical towards these interventions myself. But as a young person, I feel like this is definitely a conversation that we still need to have, even though it's difficult and it's uncomfortable. And yeah, I wouldn't want to be here. Sorry, we don't have time for another question. Thank you so much, everyone.
Thank you. Thank you very much. Thank you to our esteemed panelists, to Sustainable Population Australia, the International Society for Ecological Economics. Also, thanks to Sustainable Development Solutions Network and the Climate Protection and Restoration Initiative, and to all of you for attending this presentation.